Hello friends, thank you for showing your interest by enrolling for the course. From Craving Gyan YouTube channel, we have come up with a course for UGC NTA Electronic Science Paper 2. Paper 2 consists of 10 subjects. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. If you are visiting first time to my channel, make sure you go to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. Please do inform to your friends in order to enroll for the sessions. On the first day, we have talked about network analysis. In network analysis, we have discussed like what and all the important topics are there. And in the second lecture, we have talked about control systems. And in control systems, we have talked about block diagram and signal flow graph. And in yesterday's lecture, we have related analog electronics and digital electronics side by side. We have emphasized more on digital electronics, stating that we will be having so many advantages if you are converting given any analog signal to digital signal, and then processing it will be very much easy, like that we have explained. But the base point is analog electronics. So how we are going to deal this subject, how we are going to deal this analog electronic subject is also very important, because on the basement level we are going to analyze the signal or we are going to process the signal. Now look at the things carefully. If I am talking about an analog signal, giving an input and getting the output, so for which and all the devices I can provide like this, with respect to syllabus point of view, if I am speaking, it will be first is we have to talk about operational amplifier. So once we are very much familiar with respect to an operational amplifier, we need to emphasize on BJTs and MOSFETs. So refer to the previous year question paper. Have they not asked the question from BJT or from MOSFET or with respect to an operational amplifier? And with respect to operational amplifier, they are going to speak with respect to the Fairchild company one, that is MUA741. If you are strictly preparing for UGC NET exams, the first thing is we have to know what is the previous year cutoff. See, the previous year cutoff for JRF, it was 206, and out of say suppose 2000 plus members, only 9 members have been awarded with respect to JRF. So we have to think that we will be one among that 9 members. So this should be our vision. So similarly, say suppose if you are very much satisfied only with respect to an assistant professorship, so if you are among one among 182 or one among 90, then definitely we will be getting an assistant professorship. And say suppose if you are from unreserved category, then we should be one among 90. And for JRF, say suppose if you are one among 9 or like close to that, then it will be very much easy. Like easily we will be getting awarded. Now you talk about the percentage of getting selection with respect to JRF, it is hardly 5 to 6%. And then for an assistant professorship, top 15% members they will be selecting. So here the selection is based on others like criteria, in the sense how they have given the exam, or what's the best way they have given the exam. So what I mean to say is, if you are having a proper strategy of preparing for the exam, then definitely we will be getting the result, or we can expect some good result. Now, in the yesterday's lecture, we have talked about the digital electronics. Now, in this today's lecture, let us talk about analog electronics. Now, in this analog electronics, first thing is like since all the signals are analog in nature, so processing will be very much easy. But the thing is like each and every of the values should we consider is the biggest question. So say suppose right now I am speaking. So the signal, if I am emphasizing, it may be something like this. So should I consider each and every values? Should I consider each and every values? Each and every values in the sense what? I'll be getting an infinite set of variables or infinite set of numbers. So storing this infinite set of numbers is very difficult. This is first thing. And the second thing is, are we in need of that entire infinity numbers or infinity values to represent my signal, or to represent what I said, or to process what I said? So what extra thing we are going to do is, like say suppose 1,000 values are there. What I'm going to do is I'm going to skip some intermediate values. So I'll be having only 200 set of values. So with this 200 set of values at the receiver end, can I able to regenerate it is very important. Can I able to regenerate is very important. So the continuous signal I'm going to split into parts. The continuous signal I'm going to split into parts and then I'm going to use it. I'm going to use it. So these things we are going to discuss in detail with respect to the signals and system subject. But with respect to this analog electronic subject, so all the subjects you try to relate side by side or you keep it side by side. So which and all the subjects we can keep it side by side? First thing is you talk about analog electronics, then you talk about digital electronics, then you talk about the power electronics subject also. So this is also important. Now for an electronics or an electrical fellows, what is very important for us means we will be speaking with respect to voltages or current. We will be speaking with respect to voltages or current, or we will be talking about the power levels. With respect to analog electronics, which and all the elements will be operating with op amp, will be operating with IC. Nothing but 741 is an IC, 555 timer is an IC. So like this, we will be treating with integrated circuits, and we will be speaking with respect to the BJTs and the MOSFETs. So maximum operating voltage, if I am considering in an analog electronic subject, it is say suppose plus 15 volts, plus 15 volts. This plus 15 volts sometimes we will be using in op amp, will be giving for DC bias. And even in the case of BJTs also, we will be giving this plus 15 or plus 12 volts. It depends. Now, what is the current rating? If I'm writing capital I, it represents DC. Small I, if I'm writing, it represents AC. So worst case will be taking milliampere range. Milliampere range is the usual current range. Or else, the best possible way if you are going, we can get into maximum of ampere range. Ampere range. And what is the power level? What is the power level? It is milliwatt. It is, we are going to deal with milliwatt range. Now, with respect to digital electronics, plus or minus 5 volts is itself is maximum. You are going to deal with plus or minus 5 volts. Then current is in the order of microamperes. Similarly, power will be in the order of microwatts. Power will be in the order of microwatts. In the digital electronics, we are going to provide the input signal, and the input level will be plus 5 volts or 0, or minus 5 volts 0. Like this we are going to deal. And for which and all the equipments we are feeding means we are feeding to integrated circuits, that is IC. Because if you want to realize something, what is the base material? The base material is we are going to make use of integrated circuits. We are going to make use of integrated circuits. Now, with respect to power electronics subject, if I'm talking, so the power electronics, what is the voltage range? It is hundreds of volt. It is hundreds of volt, and current range is hundreds of ampere. Current range is hundreds of ampere. Now, what is the power level we are discussing? The power level is with respect to the power electronic subject is kilowatt to megawatt we are getting. Kilowatt range to megawatt range. Now look at the things carefully. Now look at the things carefully. See, in this analog electronics and in digital electronics, what is the efficiency we are going to consider? And in power electronics, what is the efficiency we are going to consider? And in power electronics, what is the material for which we are going to feed? One is, say, suppose we are going to feed to an SCR, right? And then we will be feeding to some of the diodes and some of the elements like commutator circuits. Like this, we will be having. And then we can feed it to transformers also. Even the transformers we can classify under, or we can put it under power electronics. Now look at the things. What is the efficiency we are expecting? What is the efficiency means a 90 plus percentage is the minimum one. If I am speaking with respect to an transformer, what is the efficiency I'll be expecting? 95 plus is the efficiency. But you see, in the case of analog electronics and in digital electronics, at max, what is the percentage we are going to get? 50% is the maximum one. Maximum value is 50%, or it will be less than 50%. Less than 50%. But here it should be greater than 50%. Why? See, even a 1% loss is a huge loss in the case of power electronics, right? Even the 1% loss occurs like more in terms of lakhs only. But in the case of analog electronics subjects and digital electronics subjects, we'll be talking about those elements where efficiency is less, but then we are least bothered. We are least bothered. Why? Maximum the power weightage will be power loss will be in the order of milliwatt or microwatt. Say suppose you are earning 50,000 per month. Your salary is 50,000. All of a sudden, if you are losing 500 rupees or 1000 rupees, that doesn't matter for you. But say suppose if you are into like stock markets and all, at that time, all of a sudden there is a crash of 40,000. Then it creates a huge negative impact on you, right? So what I mean to say is which subject, in what way we are discussing is also very, very important. In what way we are going to relate or we are going to study is also important. Now in this analog electronics, see, with respect to syllabus point of view, the first thing is we are going to talk about an operational amplifier. Now, with respect to an operational amplifier, what and all the questions they have asked, let us talk about it. Then, see, we are going to talk about the diode. We are going to talk about the diode. Diode based problem is also important. Why I am telling diode based problem is also important means see this like diode based problem you will be asking with respect to analog electronics, and you can't tell diode belongs to only analog electronics. Will it not belong to even network analysis also? Yes, it do belong, right? So given any question, we can't tell or we can't tell that with respect to analog electronics, uh, like whatever the knowledge we have gained from analog electronics subject, we are in a position to solve this diode based problem. No, if you are very much good at networks also, we can able to solve the problem so easily, right? Or else say suppose if you are good at signals, then also you can able to solve the question so easily. So next we are going to emphasize on BJT. But here one more miscellaneous topic is there. Here one more miscellaneous topic is there. That miscellaneous topic is we are going to speak with respect to rectifiers. Right? We are going to speak with respect to our rectifiers. And after that we are going to speak with respect to clippers and clampers. This is important. Clippers and clampers. Right? Match the following base question they will be asking. When we took the session for metro at that time, like in last 2023 only, they have asked for match the following base question, right? With respect to clippers and clampers, they have asked. Now the beauty is, see why I am telling you should solve other exam papers also, because each and every person will be doing just a copycat. Each and every person will be doing just copycat. You refer to UGC NT papers also, just the value they will be changing and wordings they will be changing. They are going to give the questions. So if you are preparing for only for UGC NT, what I recommend is you just give papers or you just solve previous year question papers of other exams also. What I personally recommend is solve gate papers. Upon studying with respect to BJT, next we are going to study with respect to MOSFET. Study with respect to MOSFET. At last, we are going to stop it with the multivibrator. With the multivibrator. Now, one more topic is there. Sorry, that is oscillators. oscillator. You just refer to the previous year paper, and if you're having this analog electronics notes with you, you just think of it. How much time you are taking in order to cover this analog electronics subject, and are the questions are not familiar for you? Are the questions are not familiar for you? Like this, if you are having a strategy, then it's good. If with respect to analog electronics point of view, at least you can score, at least you will be getting minimum 10 plus of marks from this subject. But sometimes what happens is, with respect to say suppose power electronics, in few years they will not be asking even a single question, but one of the year they will be asking for 20 plus marks or 30 plus marks also they'll be asking. So all those dilemma will be there. But the thing is, given a question, exactly you can't tell that this question is from analog electronics only and this question is from networks only. So those kind of questions, when they have asked, no, we have to put it into both the categories. We have to put it into both the categories. So in this today's session, let us talk about operational amplifier and a little bit of diodes, rectifiers we are going to emphasize. So, but before that, if you are having any doubts, you can ask me. Any doubts? Orchid Rose, Vivek, Nageshwar Rao. Vivek, are you there? Orchid Rose? Okay. Orchid Rose? I didn't get any response from you. Okay. So I guess you can relate with the things what I'm explaining. Now, with respect to an operational amplifier, we have made a dedicated video and I have uploaded. But the thing is, what sort of question they are asking, and if they are asking the question, how to answer it is also important. The thing is, if you are making a silly mistakes with respect to these topics, somewhere it creates a negative impact on our results also. Even one question marks is also very very important. The 2 marks if you are losing, you are gone. Simple questions if they are asking, and if you are not in a position to answer, then we feel somewhat bad. First thing is op-amp stands for operational amplifier. So what questions they may ask in order to make the question difficult? What they are going to do is they are going to connect to two op-amps in cascade. And for the first op-amp, if they are giving some input and they are expecting what is the output on the second stage. So that means what we have to consider each op-amp individually and we have to solve. Nothing but like the first configuration is, say suppose it is connected in inverting mode or non-inverting mode, or it is summing amplifier or difference amplifier, differentiator or integrator or a buffer. Like this we have to solve. With respect to op amp, what and all the things they ask is, see, operational amplifier. Amplifier in the sense what you'll be having voltage amplifier or you'll be having current amplifier, not the power amplifier. So operational amplifier, if we are studying with respect to voltage amplifier and current amplifier. Apart from that, two more things are there, that is a trans resistance amplifier. And one more category we can make, that is trans conductance amplifier. Right? Voltage control voltage source, voltage control current source, current control voltage source, current control current source. You refer to 2023 Metro paper. What actually the question is, operational amplifier will behave like all four options they have given. That means by default, how it is behaving like an voltage amplifier. So he is asking basics, or he is focusing on only on basics. We have studied with respect to operational amplifier. Say suppose knowing all the configuration, what extra thing you may ask is, what is inside operational amplifier? What is inside operational amplifier with respect to the subcomponents you may ask. With respect to subcomponents, he may ask. This operational amplifier, this operational amplifier, what is the first stage? What is the second stage? What is the final stage? Why we have to connect in this fashion only? This sort of questions they'll be asking. Now, they will not be asking like operational amplifier is a single line package or dual inline package. No. How many pins are there? 8 pins. This kind of silly questions they will not be asking. Dual inline package means see if 4 pins on one side, 4 pins on other side. This pin configuration is important in exams. They will not be asking. Sorry, they will not be giving. Pin configuration we have to remember on our own. So pin number 1, 2, 3, 4 starts from notch left side. 5, 6, 7, 8. Pin number 1 and 8 you go for no connection. Pin number 2 if I am telling, can anyone tell me what is pin number 2? Pin number 2. Inverting input. Inverting terminal or inverting input. Pin number 3 is non-inverting input. Non-inverting input. That means look at the things. We can provide input with respect to 2 pins, or 2 pins are used to fetch the input value. So on the one side you can give positive input, on the other side we can give the negative input, or both side positive inputs you can give. Pin number 4 is minus VEE or minus VCC. Pin number 7 is plus VCC. Tell me what is pin number 5? Tell me what is pin number 5? Offset. Offset. Based on this offset also, questions they have asked. Offset current and offset voltage. Now look at the things. Biasing we are going to provide at the 2 pins. Biasing we are going to give at 2 pins. Pin number 7 and pin number 4. Look at the things carefully. Look at the things carefully. How I have written also matters. Pin number 7 I have written plus VCC. Pin number 4 I have not written a minus VCC. Can anyone tell me why I have written a different notation? Pin number 7 I have written plus VCC. Pin number 4 I have written not minus VCC. I have written minus VEE. Can anyone give the answer? Now, look at the things. If say suppose if I have connected a minus VCC, or if I am taking this one as minus VCC, that means what? Operating range I am restricting. Operating range I am restricting. In what sense? Say suppose VCC is 15 volts. I have to give minus VCC as a minus 15 volts. Right? So here I'm putting a restriction. What is there on the positive, even on the negative also it should be something like that only. So that is usually not there. That is that kind of restriction we are not giving. That kind of restriction we are not giving. So say suppose if VCC is a plus 15 volts, minus V is minus 10 volts. Like this also we can operate. Or the best way is we can operate at 15 volts comma 0 volts. We can operate at 0 volts or minus 15 volts. Like this also we can operate. Or we can operate at a plus 5 volts to minus 5 volts or minus 10 volts also. This kind of full flexibility we will be having in operational amplifier. That means what is the positive value or positive biasing, negative biasing also magnitude wise it should be same. Like that restriction is not there. Restriction is not there. We can give any set of values. We can give any set of values. This is important. This is important, right? That's why I have written it as a minus VEE. Now, with respect to digital electronics, how you can able to relate? Say suppose on the output side, if you are getting more than 13 volts, I'll be treating it as logic one, and less than less than minus 8 volts if I'm getting, I'll be treating it as a logic zero. For this, plus 15 and minus 10 volts. Correct, no? Logic 1 means what? Highest possible value that the circuit can take. 0 means what? It's the least value of the voltage what the circuit can take. Offsets we are going to give. Nothing but what we are going to take, say, suppose plus or minus 2 volts or plus or minus 3 volts. The difference it may have. Now look at the things. Pin across the pin number 6, we are going to measure output. We are going to measure output. Now, one thing what we have to observe is we are having two inputs. We can provide two inputs. We can provide two inputs. How this will be processing is also important. How these things will be processing is also important. You refer to my series of lecture. How I will be explaining is, see, first thing is we will be speaking this operational amplifier as an ideal scenario. We'll be considering it as an ideal. Then upon knowing what is inside, then we'll be telling in this world nothing is of ideal. Let us talk about practical things. Let us talk about practical things. So this is pin number 2 inverting terminal. This is pin number 2 inverting terminal. This is pin number 3 non-inverting terminal. Pin number 7 is given as what? Plus VCC. Pin number 4, we are going to connect to minus VEE. And pin number 6 is what? Output. Pin number 6 is what? Output. We are going to give a feedback. We are going to give a feedback from pin number 6 to pin number 2 or or. Even this is also possible. Even this is also possible. Even this is also possible. We can't tell that we will be having the feedback from pin number 6 to pin number 2 only. No, even we can give a feedback to pin number 6 to pin number 3. That means what? The operational amplifier, you can connect it as a positive feedback one or a negative feedback one. Or a negative feedback one. But most of the cases, we are going to give a negative feedback only. Why? There are some reasons. There are some reasons. Usually not preferred. Which feedback? Positive feedback not preferred. Why we are not going to prefer means, see, op amp in positive feedback will be acting like what? Op amp in negative feedback will be acting like what? This is also important. This is also important. Now what I mean to say is, with feedback, with positive feedback, it is acting like an oscillator, not at all interested. Negative feedback, it is acting like an amplifier, very much interested. Right? So what I mean to say is, see, in the last topic of the syllabus, oscillator, there we are going to talk about the positive feedback. In rest all the cases, we are emphasizing only on, or we are focusing only on the negative feedback. Only on the negative feedback. Very, very important. Very, very important. Now, all the pins I have discussed, pin number 5 is very, very important. Pin number 5 is very, very important. And after explaining this pin number 5, let us talk about the inputs and outputs. Let us talk about input and output. Now, say suppose, let me consider. If I'm waking up, then I should be in a position to study the subject. Nothing but what? I'm out of sleep. Right now, I have to focus. Will the focus will come once you suddenly get woken up or waken up? Say suppose at 6 o'clock you have woke up. At 6 o'clock you have woken up. And if you are sitting in front of a book, can you able to focus? No, you will be taking some time. You will be taking some time. All the day activities you are going to finish, and then you are going to sit, or you are going to settle. For that you are going to take some time. Say suppose at 6:15 you will be ready. You will be ready. So that means what? A wake up time is 15 minutes. Wake up time is 15 minutes. Sorry. Similarly, this in the case of operational amplifier or any circuit of your choice, once you are giving biasing, and say suppose if the input applied is 0, we expect we expect output also to be 0 only. Output also should be 0 only. But but output is not 0. But output is not 0. In CRO, when you are conducting an experiment, at the time you will be getting that offset a little bit shifted or little bit downshifted, or it will be tilted. So what we are going to do is, with the help of one resistor connected to pin number 5 and VCC, we are going to tune it. We are going to tune it such that it should align at origin, and we expect output to be, or output showing 0. So once it is 0, then we are not going to change the knob position which is connected to pin number 5, and later we are going to operate the circuit. Later we are going to operate the circuit. So this is the beauty of pin number 5, that is offset. What is the significant of offset? I have explained. Now look at the things. So pin number 2 and the pin number 3. If I am telling you will be having two inputs. So if I am having two inputs, can I tell it is operating like what? Differential input, differential inputs, then a single-ended output, single-ended output. That means what? One of the value is pin number 6 and another value is what? Ground. Another value is what? Ground. Now, with respect to analog electronics, what is the load? What is the load? Load is always a resistor. Occasionally, it will be worst case a capacitor or inductor. 99.99% it is a resistor only. It is a resistor only. Important, important, right? But with respect to MOSFETs, if I am speaking, it will be capacitor. With respect to electrical fellows point of view, load is always taken to be an inductor. Load is always taken to be an inductor. Now look at the thing, how it is a differential input, single-ended output. Now, if you are considering an inset, what is there? So we will be getting the configuration something like this. We will be getting the configuration something like this. This one we will be taking it as RC1 and RC2. The output over here, let me take it as V02. Output over here, let me take it as V01. V input 1, V input 2. RE, and here you will be having 0 or minus VEE. Even this is also possible. And here we will be having plus VCC. Plus VCC. Now, what is one thing we have to note? What is one thing we have to note? See, we will be having two inputs. What are the two inputs? V in 1 and V in 2 are the two inputs. What are the output means what? V01 and V02 are the two outputs. This is a differential input and differential output. Differential input and differential output. Right? Next configuration is, see, we will be having a differential input but a single-ended output. That means what? Two inputs we are connecting, but single-ended output means what? V naught one if we are considering, then V naught two is taken to be ground. V naught two will be taken as ground. Now, say suppose when it is differential input and differential output, what is the output at the time? It is V naught one minus V naught two, or it is V naught two minus V naught one. Either of the things we are going to consider, V naught one minus V naught two or V naught two minus V naught one. It depends on how you are considering. Now look at the things with respect to differential input and single-ended output. We are having two inputs, but we'll be considering only V naught one. V naught one if you are considering. So output will be V naught one. With respect to ground, we are not at all considering V naught two. V naught two, we are not at all tapping the value. We are not at all taking the value. Next, we will be having a single-ended input and differential output. That means what? Say suppose if I am considering V in 1. Say suppose if I am considering V in 1. V in 2 I will be considering it as a 0. V in 2 I am not at all connecting. Then we are going to solve. Then next one is a single-ended input, single-ended output. That means what? I'm going to give V in 1 and I'm going to take, say suppose V naught 1 or V naught 2 also I can take. V into I'm not at all using. Vice versa is possible. So this is single-ended input and single-ended output, or single input and single output. Now this operational amplifier will fall under which category? Differential input and single-ended output. Differential input and single-ended output. This is very, very important. Any doubts? Hello? Jamshid Singh. Good. Vivek? Okay. Now we have talked about like a little bit we have emphasized what is inside, or how the symbol got evolved, why the symbol is something like a 2 3 7 4 6, or the based on the pin configuration. We have explained how many inputs are there, how many outputs are there, where exactly you're going to tap the output values. All those things we have considered. Now, all those things we have considered. Now, this operational amplifier will be used as what? This operational amplifier is used as what? But before to that, see, you refer to any lectures of few persons uh, that's been already been uploaded on YouTube. What they will be doing is this much they will explain. Then straight away they will be taking operational amplifier as a inverting configuration, non-inverting configuration. Straight away they will be getting it. But before to that, few of the terminologies are there. Those things we have to consider. Those things we have to consider. Now, one thing what I told is op amp initially I'll be considering it as an ideal scenario. Then non-ideal, anyway, if we will be knowing that it is behaving like a non-ideal. So what and all the corrections we are going to make, that one we are going to do it later. But as of now let us consider operational amplifier as in a ideal scenario or idealistic scenario. For this, look at the way what I sorry how I explain. This is inverting terminal and this is non-inverting terminal. And say suppose what is the level of biasing I am going to do? Minus VCC and minus VEE. Output I am going to measure or I am going to take across pin number 6. Now, what is the output range? What is the output range? Now, output range can't exceed VCC, and on the negative side it can't exceed minus VEE. Now what I mean by this? What I mean by this? Say suppose if I am considering op amp as an amplifier, if I'm considering op amp as an amplifier. If I am giving 1 millivolt at the output, I am getting 1 volt. 1 millivolt at the input, I am getting 1 volt at the output. There is an amplification factor of 10 power 3. Well and good. Well and good. Say suppose if I am applying a 2 millivolt, what is the output? 2 volts I am getting. Similarly, if I am applying a 10 millivolt, amplification factor is fixed, so I'll be getting 10 volts, right? Say suppose if I am choosing this values as a plus or minus 15 volts. That means if my input is say suppose 14 millivolts, I'll be getting output as 14 volts. If I am giving my input as 15 millivolts, I'll be getting 15 volts. If I am getting 16 milli, if I am giving 16 millivolts, if I am thinking that I'll be getting 16 volts, it is wrong. If I would have got, then what I'll be doing is I'll be feeding a minimum of 1 volt at the input. Then I'll be getting how much? 1000 volt at the output. So I would have started my own powerhouse. I would have started my own powerhouse using a simple operational amplifier. So practically it is not possible. Practically it is not possible. That means what? Op amp is getting saturated. So in this case, op amp is getting saturated. Now one more thing what we have to understand is one more thing what you have to understand is, see, my output my feedback sorry my power supply is plus or minus 15 volts. Output will not be getting plus or minus 15 volts. Still less only it will be restricting. The maximum you may get plus or minus 13 volts, or worst case you consider plus or minus 14 volts. What the standard author textbook says is like this output is saturated. To how much means power supply value to minus 1. So output will be getting saturated to plus or minus 14 volts. That 1 volt difference will be there. That 1 volt difference will be there. But ideally, if I am speaking, I can reach up to plus or minus 15 volts. I can reach up to plus or minus 15 volts. Very, very important. Right. Next, the beauty of this operational amplifier, what is inside means, see, you will be having a resistor kind of thing. You will be having a resistor kind of thing. So this is pin number 2 and this is pin number 3. The voltage over here I'm going to represent as V minus. The voltage over here I'm going to represent as V plus. Usually what we expect is this V minus value is same as V plus value. V minus value is same as V plus value, right? So virtual short concept do exist. Virtual short concept do exist. Now look at the things. Both are at the same potential. Both are at same potential. 3 volts over here, 3 volts over here. What is the current that is being flowed inside? So current will be approximately equal to 0. This is in ideal scenario. So current getting into op amp is 0 in ideal. But practically if you are considering, so the current value will be in the order of microamperes. Practically, right? Microampere range of current do flow. Microampere range of current do flow. So let us talk about what is the input resistance that is being offered. So with respect to these things, input impedance is current is 0, impedance is infinity. In which scenario? Ideal scenario. Really it is possible? No. What is the impedance? It is in the order of mega ohms. It is in the order of mega ohms. So what I explained is I have explained the concept of virtual short. I have explained the concept of virtual short. With respect to this concept, what I told is current getting into operational amplifier is zero. So practically you will be getting in terms of microamperes. Maybe because of that they have uh, given that mu. Right? I don't know. So and the company is from Fairchild. Now, current is in the order of microamperes. Input impedance is a mega ohm range. Input impedance is a mega ohms range, right? And few textbooks, what they will be telling is a 10 power 5 to 10 power 6 of ohms. 10 power 5 to 10 power 6 of ohms. 10 power 5, zero point 0.1 mega, zero point 0.2 mega, zero point 0.3 mega. So I told it is in the order of mega ohm range. It is in the order of mega ohm range. Now let us talk about the characteristics. You refer to previous year question paper. Have they not asked the question from the characteristics? Simple way, 7 to 8 characteristics are there. Those 7 to 8 characteristics, if you are studying or if you are knowing, then definitely will be getting one. One question we can able to get through. So this characteristics of an operational amplifier is important. Then later on, let us talk about the configuration also. Let us talk about the characteristics of an operational amplifier. Let us emphasize what it is all about. When I'll be speaking with respect to the characteristics, we need to speak with respect to ideal scenario, under ideal scenario, and under practical scenario. Tell me the first characteristics. Say suppose if I am telling gain. Tell me what is the gain with respect to open loop if I am considering. Hello? Tell me now. What is the range of gain? The range of gain is infinity. Practically, it should be 10 power 6. 10 power 6. In the closed loop gain, we will be getting less only. We will not be getting infinity. Very, very less. Very, very less we are going to get. Right? Now, you please talk about input impedance. Hmm. Few textbooks they will be calling it as input resistance also. But in general, if I am speaking, it will be input impedance. Here it will be infinity and here it will be zero. Hmm. Tell me what is the output impedance? All of you open your mouth. What is the output impedance? Hmm. Output impedance ideally zero. Practically, uh, textbook says 25 to 75 ohms or 100 ohms you consider. Few textbook says 50 to 100 ohms. Few textbook says 50 to 75 ohms. So 25 to 100 ohms is the ideal scenario. Sorry, practical scenario. Now you talk about the bandwidth. You talk about the bandwidth. Tell me now, what is the bandwidth value? Infinity megahertz range. There are three more parameter. One is common mode rejection ratio, power supply rejection ratio, then sleeve rate, then input offset current, then input offset voltage. These things are there. We have to go through. Right? In a vague way of explanation, if I am telling common mode rejection ratio, it will be expressed as what? Differential gain to common mode gain. Right? So what do you mean by differential gain? What do you mean by common mode gain? Let us talk about it. Usually we are going to express this CMRR in decibel level. In decibel level. Refer to previous year question papers of UGC NET. Have they not asked the question with respect to CMRR? Problems they have asked. Power supply rejection ratio, this is very, very important parameter. And what do you mean by sleeve rate? Sleeve rate is important. See, say suppose right now I've taught you operational amplifier. How best you can able to grasp the things what I said is important. If you can able to grasp the things suddenly, then sleeve rate of your brain is more. If you need a revision, then if you are in a position to understand the things properly, then sleeve rate of your brain is less. Nothing but see input levels. Say suppose if it is varying something like this, output will it get sudden change? No, you will not at all getting. You will be getting a ramp kind of thing. How steep is the ramp? What is the slope? This is important. Say suppose if it is something like this, sleeve rate is best. Sleeve rate is good, right? How best you can able to change the catch the changes with respect to your input. That is how you can define sleeve rate. That is how you can define sleeve rate. What is the current that is getting into? What is the voltage that is an offset when you turn on? It is important. So these are some of the characteristics of an operational amplifier, which is very, very important. So they will be speaking with respect to the ideal scenario and practical scenario also. So ideally, what are the characteristics of an operational amplifier? What are the practical characteristics? So this table, like if you can able to remember, like minimum 2 marks will be in your pocket. Now let us talk about the configuration of an operational amplifier. One or two configurations. Say suppose you are in need of that virtual short concept. We can explain that one also. The first configuration is inverting terminal configuration or inverting amplifier. Now, what do you mean by inverting? Inverting means what? Applying input at the only at a inverting point, expecting the output is getting amplified. Output is getting amplified. Important. Let me write a symbolic way of representation. Minus plus. This is pin number 2, and this is pin number 3, and 7 and 4 will be for bias. This is pin number 6, output. Now look at the things properly. Pin number 3 is non-inverting terminal. So we are realizing for inverting amplifier. So non-inverting we have considered to be at ground potential. We have to restrict the current flow. We are going to make use of a resistor. Some amount of output will be fed back, so that we will be knowing whether we are getting the output properly or not. So we are going to consider the feedback element to be a resistor, that is RF. Input we are going to provide through a resistor R1. I'm going to call the input as V in 1. I'm going to call the input as V in 1. So overall this is the configuration. Overall this is the configuration. Now look at the things carefully. What is the one line of statement I told? Virtual short is valid. Virtual short is valid when op amp is connected in negative feedback. Sorry. Now look at the things. Is op amp in negative feedback? Op amp in negative feedback. Then true. Op amp is in negative feedback. Second thing what we have to know is op amp not getting into saturated. Op amp not getting saturated. When the op amp is not getting saturated, these two conditions are satisfied. Then we can tell virtual short is valid. virtual short is valid. What do you mean by virtual short? You'll be getting a V minus potential as a V plus potential. Uh, what is V plus potential? 0. What is V minus potential? It will also be 0 only. It will also be 0 only. Physically, you are not at all connected. Physically, you are not at all connected. But because of this virtual scenario, we are going to get what? V minus, which is the same as V plus. V minus, which is same as V plus. Very, very important. Right? Now, the current that is getting into, I'm going to call it as I1. The current that is being fed back, I'm going to call it as IF. The current that is getting into op amp, I'm going to call it as IG. This point is a virtual short or virtual ground, so I'm going to represent it as G. I'm going to take that point as G. Now, let me apply KCL at node G. KCL at node G. What it says, incoming currents equals to outgoing currents. What are the incoming currents? I1 is the incoming current, IF is the incoming current. What is outgoing current? IG. What is the value of IG? 0. Why? The current that is getting into op amp, what I told, 0. Such a simple thing, right? So the current that is getting into an operational amplifier is 0. So in an ideal scenario, so I've equated to 0. Now what is the value of IF? IF equals to minus I1. Another way of KCL, how I'll be writing is all the currents are leaving. When all the currents are leaving, the current is moving from 0 to V in. But the current I1 is opposite, so I'll be taking it as a minus I1. Even IF is also minus only, so it is minus IF. IG is in the same direction, I'm going to take it as 0. So what I'll be getting, if I'm sending entire terms, these two terms on the right side, I'll be getting IG equals to I1 plus IF. Same expression. So KCL, how you have studied is also important. Given any question for you give any question for me, what I'll be doing is I'll be considering all the currents are leaving the node. Few persons they will be considering all the currents are entering the node, and few persons they are going to do a proper guess. But I'm not at all bothered. Just all the currents are leaving. Based on the reference currents, I'm going to change the sign of it. Now, what is the value of this current, that is IF? IF is what? The current that is flowing from V0 to Vg divided by the resistance value is Rf, which is equal to minus of. What is the value of I1? I1, the current is flowing from V into Vg divided by R1. What is the potential of Vg? 0. So what I got? V0 divided by Rf, which is equals to minus V in divided by R1. V in divided by R1. Now what do you mean by an amplifier? In terms of voltages, if you are considering V0 divided by V in, which is equals to voltage amplifier, which is equals to a minus Rf divided by R1, minus Rf divided by R1. Very, very important. Very, very important. So what I got the gain value? What I got the gain value? Gain, which is equals to minus Rf divided by R1. Gain, what is the value I got? Minus Rf divided by R1. Keep these things in your mind. Slowly we are going to do an analysis. Slowly we are doing the analysis such that it will benefit you. Now, the gain of an operational amplifier in the case of inverting terminal, what I got, which is equals to minus of Rf divided by R1. What is the input impedance? What is the input impedance in the case of inverting amplifier? Input impedance. Input impedance is how much Rin is the input impedance or R1 is the input impedance. Now look at the things carefully. Now look at the things carefully. For gain to be an higher value, for gain to be an higher value, what has to be kept more? RF has to be kept more. If I am increasing the value of RF, IF current will not get it. So what I should do? The best possible way is R1 have to decrease. R1 have to decrease. R1 have to decrease for getting more gain value. If I am decreasing the value of R1, now what is the thing that is going to happen means that this input impedance decreases. This input impedance decreases. When this input impedance decreases, what is the thing that is going to happen? Slowly the current gets entered. Slowly the current enters. Slowly the current enters. What you will be getting? Offset you will be getting. What you will be getting? Offset will be getting. Now say suppose current is flowing. Current is flowing. V plus anyway connected to ground. V minus at the time, since current is flowing, V minus will not be equal to 0. So at that time, what you will be getting? V minus not equals to V plus. What is the problem? Virtual short is not at all valid. Virtual short is not at all valid. When virtual short is not at all valid, right? You can't take this equation. That is I1 plus IF which is equals to IG. You can't get. When you are not getting, none of the things what I explained till now is valid. So there is a limitation of R1 beyond which you can't decrease. So that means you want gain to be a more value, then what is the sacrifice you have to do? Input impedance you have to increase. Sorry, you have to decrease. Nothing but can I tell trade off exists between which two parameter? Gain and input impedance. Gain and input impedance. Very important. Very important. Trade-off is going to exist between gain and input impedance. Right? So this is all about inverting amplifier. This is all about an inverting amplifier. Non-inverting amplifier also similar kind of thing, but what is the gain value we are going to get? 1 plus RF divided by R1. 1 plus RF divided by R1. What is the input impedance? There you will be getting infinity. There you will be getting input impedance as infinity. That means for the gain value you want more 1 plus RF divided by R1. R1 can be very less, but then also it is not affecting the input impedance. It is not affecting the input impedance. Let us know about it now. Let us talk about non-inverting amplifier and then we are going to end the session. Right? We are going to end the session. Now, Vivek and Nageshwar, any doubts? Hello? Let us talk about non-inverting amplifier and then we can do a quick recap and then we shall compare non-inverting with inverting amplifier. In a fresh page only I'm going to start. Let us talk about non-inverting amplifier. Non-inverting amplifier. In the case of non-inverting amplifier, non-inverting means what? Providing input at the non-inverting terminal, that is pin number 3 and pin number 2 not at all touching. Now look at the things. I'm going to provide input at the non-inverting terminal. Few textbooks what they'll do is from the positive they're going to connect a resistor, then after that resistor they're going to give this V in. The thing is, whatever the value of resistor you consider over here, that doesn't alter the current that is getting into. That resistance can't alter the current that is getting into. So resistor is not a controlled one. Inverting side will be having this R1 and feedback will be there. RF, and this is V0. This point considered to be ground point. This point considered to be a ground point. Now look at the scenario. Now look at the scenario. Feedback current is this one. Feedback current is IF. From where to where it is flowing? It is flowing from V0 to VG. V0 to VG. Now, the I1 current that is flowing from where to where? It is flowing from VG to ground. It is flowing from VG to ground. Now, VG to ground. Now look at the things. Now look at the things. At G, at virtual ground. Can you tell me what is the voltage at virtual ground? Hello? V in. Good. You are going to get a V plus, which is same as V minus, which is equals to V in is the potential you are going to get. V in is the potential you are going to get. Now, what is the current that is getting into this operational amplifier? 0. What is the current that is getting into operational amplifier is 0. Now, at node G, at node G, Vg equals to V in. But what is the value of Ig? Now also it is 0. At a node, no any current should be there. Nothing but whatever the current that is getting into, it should move out. It is not at all a storage element. Incoming current equals to outgoing current. We know that incoming current equals to outgoing current. So incoming currents are what? IF is the incoming current. What are the outgoing currents? I1 is an outgoing current plus IG is an outgoing current. What is the value of IF? Voltage divided by resistance. Highest potential is V0. Lowest potential is Vg. That is V in divided by Rf, which is equals to what is the current? What is the current? I1. It is V in minus 0 divided by R in. R in. R in. Now, so solve it. What you are going to get is V0 divided by V in, which is equals to 1 plus Rf divided by R1. 1 plus Rf divided by R1 or R in you can consider. How it is getting means V0 divided by Rf, which is equals to V in divided by R1 plus V in divided by Rf. V in there you take common, you are going to get this value. V0 divided by V in, which is equals to 1 plus Rf divided by R1. 1 plus Rf divided by R1. Now you tell me what is the input impedance? What is the input impedance? What is the current that is getting into? 0. So it is what? Infinity. Few textbooks, how they are going to connect means they are going to connect the resistor over here. They are going to call it as 5 kilo. At this time also, input impedance is not 5 kilo ohm. Input impedance is how much? Infinity. Input impedance is how much? Infinity. Why? The current is what? 0. Current is 0. Input impedance is what? Infinity. Input impedance is what? Infinity. We are going to get. Now, are we having any restriction with respect to R1? Are we having any restriction with respect to R1? No, right? So the gain value can be increased however we want or how much ever we want. But in the case of inverting amplifier, there was a problem for us. There was a problem for us, right? So for gain to be a more value, choose R1 to be a very less value. Okay, so there is no any restriction. So I'll be writing a line of statement stating that no trade-off exists between which two parameter, gain and input impedance. Uh, Gain and input impedance. Hmm. Gain and input impedance. This is very important. This is very important, right? In the case of operational amplifier, I've talked about the gain and input impedance. And in the case of the non-inverting amplifier or non-inverting configuration also, I have explained with respect to input impedance and gain. Similarly, we have to speak with respect to a summing amplifier, difference amplifier, integrator, differentiator, a buffer. All these things are important. Thank you for being on my channel. Please like the video, share this video with your friends, and subscribe to my channel, Craving Gyan. All the best for your competitive exams. Thank you.